Hi, Hans here. If you're working with compiled software languages, sooner or later your project is going to build up to a size where compile time starts getting significant and you end up spending more and more time waiting for the compiler to finish. And at that point, I've had this with ZTFTP server, actually with multiple projects, but most recently with ZTFTP server. At that point, you start looking for ways to speed up the build process. So that's what I want to cover in this video, just a few ways that you can do this. I'll be focusing mostly on C++, but a lot of it's applicable to other languages too. So first method, buy a faster machine. It's the most obvious and the easiest one, except for your pocket. It's the most expensive option. Assuming that you don't want to buy a new machine or you can't afford it yet, the next one is to take advantage of the fact that all modern machines have multiple cores in them. And if you get all of them working in parallel, you can get your build done faster. And that's almost, actually, I'd say that's as easy, if not easier, to come to think of it. Because with make, you just type make -J and then the number of processes that you want. And usually setting that to the number of cores that you have in your machine will do it for you. And then hopefully if you've got a fast hard drive, it'll cut down the build time significantly. And at that point, if you still want to get it faster, things get a bit more complicated. So the next thing that you can do is to start trying to eliminate as many unnecessary include files. Now usually you start building up, you end up including things that you don't actually need. With Java, it's the import statement. You might see a lot of import this .star, which means import everything in this module. You want to start including just the things that you need. But you can go a step further, and I'll show you that this is one of ZTFTP server's classes. This HTTP connections list, you'll notice it has an event manager here. That's what I called the class that runs the main event loop and waits for events and then calls the appropriate event handlers. So other source files that are using the HTTP connection and connections list, they don't need to know about this event manager. So including that event manager here, up here, all that does, oh, there's a .h missing there, oops. All that does is add event manager.h as a dependency for a whole bunch of other source files that don't actually need it. Which means if I make one tiny change to event manager, a whole proportion of the ZTFTP project has to be recompiled, even though it's not actually needed. So what I can do is I add a declaration here to let the compiler know that there's an event manager. Then I can delete this or cut this out of the header file and put it into the HTTP connection C++ file, because that does need it. And there you go, one include file gone. And now, if I need to make changes to the event manager header file, it doesn't trigger a massive rebuild. And there are opportunities to do this all throughout the code. Although I have to say it's a lot easier to do if you start thinking about this when you begin the project, rather than trying to rework it later when you start realizing, hey, I don't want to be waiting 10, 20, 30 minutes for a rebuild. The FTP server is not at that level yet. It shouldn't really, but if you're working on something really big, compile time can get really huge. Now, if that's still not enough, then there are more things that you can do. There's something called the Pimple Method, which, let me bring that up. Basically what that is you have a wrapper class, or some call it a generator or whatever, which has a pointer to the actual implementation, which means that whatever includes that class has minimal other includes. Now, I avoid doing that as much as possible, and I really don't like it when I encounter C++ projects that have done that with every single class. And the reason is it's a lot of double work because you have to create two times as many header files. You've got the, not just header files, two times as many source files. You've got the wrapper, and then you've got the actual implementation. So that's 2 headers, 2 source files, 4 files instead of 2. And then you've got to keep them in sync. Every public method that the implementation has needs a copy in the outer wrapper. So I would highly recommend only using that when it's actually needed. Added to that, there is a slight runtime overhead to that too, because everything's working through a pointer. However, when needed, that can be very useful. And the final technique I've never really bothered with. It's called precompiled headers, and I don't bother with it because precompiled headers come with all sorts of restrictions on what you can and can't do. And then, at least as far as GCC is concerned, the compile time improvement is fairly minimal usually with C++. You don't get that much gain out of it. In some cases, it makes no difference, or it can even have a negative difference, so make compile times worse. I have been told that it is more effective with Visual Studio, but in this case, I do a lot of work with GCC. So those are a few quick techniques. If you found this useful, you might want to consider subscribing to this channel. I try to put out a new video every week. Otherwise, hope you are well, and I'll see you next time.